Welcome to another episode of Professors at Work. I'm Aram Yeretzian, the journalist in residence at AUB, and I'm happy to host this weekly show where we talk to professors and scholars at the American University of Beirut about the research they're doing, what they're finding, and why it matters to the rest of us. We're delighted today to have as our guest Professor Aram Yeretzian, who's assistant professor in the Department of Architecture in the Maroun Sam'an Faculty of Engineering and Architecture. And for the last 15 years at AUB, he's been teaching climate-responsive buildings and green cities and all of these different linked dimensions of environmentally sustainable and sensitive structures in an urban environment and how they ultimately respond to people's well-being. So, Aram, thank you for being with us.
Thank you, Aram. Thank you for having me.
So tell me, what does climate-responsive buildings include?
So the idea is that we cannot build conventional building blocks and then say that or work on making them more environmentally friendly. So we're starting off with a certain set of problems, which has been going on for several decades now. And then when the building is up, we say that, okay, now we need to make it environmental. So the idea is that this process, this thinking process and design process has to start at an early stage, whereby we integrate the parameters of climate, such as solar radiation, the sun, wind, as well as daylight, into the initial stages of the design, thus yielding a project. I say a project because this involves the building and the area surrounding the building, which is responsive to climate. So in an area that has abundant solar radiation, I want to design a project that in fact reduces the amount of radiation that impacts the project.
And the ultimate criteria that you use to measure whether you're doing it well or people are doing this well or not is the impact on human beings, I assume.
Right. So there are numerous and various metrics and ways of looking at this. It basically boils down to two aspects: energy use and thermal comfort. So on one hand, we are doing this to reduce the amount of energy that people use to maintain comfort inside spaces, which is changing very fast as we progress and develop technologically. And the other is, in fact, which is, in my perspective, more important, which is maintaining thermal comfort. How do people feel comfortable? How and why do people feel comfortable inside spaces, as well as outdoors?
So you're talking of heating and cooling.
Right, basically, and lighting. These are the three main parameters that if a building is not designed properly, you use more of than relying on the natural climatic parameters to enhance comfort.
And so from the research you and your colleagues are doing, what are some of the main issues that you're exploring in the research work?
So the research relates to two main subjects. First is the shape of buildings. So that's an important parameter for new buildings that will be built, given the increased rate of urbanization on the planet and the population growth. There's a lot of construction that will happen in the coming decades. So designing new buildings that respond to climate is very important. The second aspect is understanding how existing buildings behave, because existing buildings today constitute the majority of the building stock in cities. So looking at these buildings that are built since at least 80, 90 years, sometimes earlier than that, and understanding how they are behaving is quite important to make them more efficient.
And your research work is trying to identify new mechanisms, new systems for new buildings as well as adapting old buildings?
Exactly. So for new buildings, it's again related to the shape. So we don't want to build rectangular blocks and then make them environmentally friendly. We want to test and understand what is the most suitable shape in a given context. So if it's a very hot area, a building will have a shape that is very different than in a cold area.
In which way? It'll give you more shade or let wind? What are the...
So buildings in hot areas are the massing of a building and its orientation would result in less solar impact on the building. And some studies show that this could be 40% less, which is really very beneficial as a starting point for a design. So that's for new buildings. In terms of existing buildings, understanding how, so we refer to this as the building envelope, right? This is the roof, the wall above ground, the wall below ground, and the lowest slab in a building. So these four elements compose and constitute the building envelope. And understanding how this element behaves in a particular context throughout the year, so in different seasons, is very important so that we can improve its performance and make it more comfortable for the people inside.
And you do this work by working that you do the research and then you share your findings with who? Private sector contractors, government that set rules, who give licenses?
So there are two parts to this. The actual work is, in fact, all my research is interdisciplinary. So I'm working very closely with civil engineers, mechanical engineers, computer engineers to look at how these components are working and behaving. And then the idea is, in fact, to come up with recommendations, with generalities that could serve to identify or to write up policy papers, okay? And this would address all the professional body, either as an informative policy paper so that other architects and people in the building industry can benefit from this, or in terms of administrative, whereby a municipality could create guidelines for construction and renovation in the city. Beirut City has about 17,400 buildings. 80% of them were built before 1975. And so there's a huge demand to, usually in other contexts, you would need to upkeep and maintain these buildings. And so once that is done, recommendations and requirements are necessary so that this is done in an energy efficient manner.
What can you do about these older buildings? Are there ways to modify them?
Yeah, so this is a very interesting issue. So I actually measured the internal surface temperature and the external surface temperature of a wall. And that gives me a clearer understanding of how this wall is behaving in different seasons. And it turns out that, for example, in Beirut, an old sandstone wall, which is a thick wall, actually provides a lot of comfort for indoor occupants when it's very cold. Well, relatively cold, we're talking about Beirut, and when it's very hot. And thinner walls that were built, for example, in 1948, thin walls, actually work better in mid-seasons, when the outdoor ambient temperature and humidity are very comfortable. And so therefore, the insight here is that, in fact, we would like to have walls that behave differently during different seasons.
Wow.
So what if I could manage to have a wall that could perform as the thick wall when it's cold and hot, and as the thin wall when it's in the mid-season? And so, understanding this, we can identify means and methods to actually intervene on these buildings while they are being renovated so that we achieve these targets.
Do you work with individual homeowners, say, or one building, somebody's owns a building, comes to you and says, can you give me some advice on this? Or do you just try to work at a general social society and policy level?
So at this point, the general level is more interesting because of the impact. At the end of the day, addressing the major population of buildings is more interesting. But having said that, the recommendations are tailored and targeted to individual buildings. So a person who has a building built in 1956 can identify what is the wall type, and then can identify what needs to be done to improve the performance.
Mm-hmm. And what are the implications of all this on costs and the economy?
The issue of cost has two parts, right? There's the initial cost, and then there's the operational cost. So the cost throughout the lifespan of the building. We need to look at this whole broad perspective of cost to be able to identify, because it may be that there is an initial incremental cost on the intervention, but the payback period, because buildings live for several decades, makes the overall cost impact actually very, very interesting.
One of the things we noticed, just take the AUB campus, some of the newer buildings, the Masri Energy Institute, the Assam Faris Institute, the Medical Center expansion, they're all glass and concrete, glass and concrete. Is that a good thing or not a good thing?
Well, in principle, so here's the issue. The issue is that we can have glass buildings, but there's where the cost really shoots up, because this glass has to be very performant. And so to do that, first of all, it has to be imported, and that makes the incremental cost really significant. In principle, this is not the best way to do things, right? We want to have a balance between the glazed openings. Of course, glazing is very important for views, for ventilation, for different aspects of that help internal comfort or enhance internal comfort. But the building in totality should not be made out of glass. So there are particular, again, guidelines for the proportions of the glazing with respect to the opaque area, And this also relates to the orientation of the building. So the south, where the angle of the sun is high, is different than the east and the west when the angle is low, or to the north, where there's in fact the minimum amount of incident radiation. This is relating to the building itself. A very important aspect of buildings is that they exist in groups in the city. And in fact, buildings constitute what we call the negative space, which is the space between buildings in the city, where people walk on sidewalks and spend a lot of time. And that is another important aspect of how buildings affect outdoor thermal comfort. So we are also looking at the sensation that a person can have outdoors depending on the materials of a building, how much they absorb and re-radiate heat, depending on the surface materials of sidewalks and streets, as well as on vegetation. Of course, this is all related always to a particular climate. So looking at this in Beirut is different than looking at it in let's say, Dubai or Athens or Helsinki.
And so this gets you into the wider urban environment.
Right. So this is really a very important and timely issue. We refer to this as the urban heat island effect. So cities today have increased temperatures with respect to the ambient surrounding areas. And this is due to the fact that heat is trapped in cities, in buildings, in the materials of buildings and roads, and it is not easily flushed out with wind. And so therefore, when the heat is trapped, this increases the temperature in the city. This is also compounded with what we call anthropogenic heat, which is the heat generated by people in the form of cars, which generate a lot of heat in the context, as well as air conditioning systems. So it becomes kind of a vicious cycle, right? It's hotter outside, so you need more air conditioning, and then the compressor is heating further the outer environment. So all of this needs to kind of flip into a positive cycle, and this is done by understanding how buildings actually create a microclimate right next to them. You may feel while you're walking, for example, on newly paved asphalt streets in the afternoon, after they absorb all the heat, that the heat is re-radiated from the asphalt. Very, very uncomfortable situation. So again, identifying the proper materials, the proper type of vegetation, and the proper materials for buildings could be very important in improving outdoor thermal comfort.
And do we have people in Lebanon or the Arab world, to your knowledge, who actually are dealing with these issues in the public sector, who are responsible for urban design and urban licensing and things like that?
Well, other than the academic approach, which is, there's a lot of focus on this, so I really work a lot with the landscape department, with the urban lab, and with other colleagues on enhancing this. Also the issue of public health, right, and air quality is really instrumental in this discussion. But beyond that, the country lacks a strategic vision towards enhancing the spaces outdoors.
You're talking of Lebanon now?
Yes, Beirut. Yeah.
And what about other?
Abroad, no. Abroad.
Do you know of other countries in the region?
Yeah. I mean, in the region, there are stringent guidelines in Emirates, in Athens. Other Mediterranean countries are working a lot on this aspect. I mean, the importance. You see, as we advance, indoor spaces are becoming smaller, right? Apartment sizes that used to be 200, 300 square meters now are smaller, and the idea is that people would spend more time outdoors, given the benefit of being outdoor. And so a lot of importance is given to the quality of this outdoor space. And this relates to materials, vegetation, and climate.
And what about the economic impact in terms of expenditures? If you talk of all of these dimensions, heating, cooling, the structures, are there important economic or financial dimensions to the economy as a whole, or to individual people, contractors who build buildings?
Sure. So the issue of the economic aspect is very important, but it needs to be studied, right? Because it differs tremendously, let me say, based on scale of a project, based on scale of intervention. So as every project, you have to take into account a budget and work accordingly. And so in this case, it's the same, knowing that in all of these environmentally driven initiatives, the long-term benefit is tremendous, especially when we talk at the urban scale. The benefits are first, in terms of comfort, second, in terms of health and quality, which impacts the health sector. So really, the ramifications pertain to different disciplines and dimensions, and the compounded effect is definitely very, very beneficial to people.
And what happens when you add in the climate change expectations?
So that's a very important aspect because so when we do our simulations and modeling, we actually more often than not, cater for the scenario of climate change. So based on either 1.5 degrees as per the Paris COP or even higher, because that's an average. So in particular parts of the world, it will actually be higher or lower. And so therefore that kind of underlines and highlights the importance and the crucial aspect of this issue that needs to be discussed and implemented as of yesterday.
Wow.
Yeah.
Is it being discussed and implemented in the public sphere as far as you can tell?
Again, depending on where we are on the planet. So in North Europe, really very advanced in these issues, and in some other parts, unfortunately, we're lagging behind in this subject. Although we have a climate that allows many opportunities to address this, is Mediterranean climate, but unfortunately, due to lack of a vision and the strategic initiative to put all of this together, it remains based on individual, projects or individual people that have the awareness and the knowledge to actually deal with this.
One of the things that we're discovering with our discussions with professors in this series, particularly people who work in urban studies or environmental issues or water or climate issues, that they're doing academic scientific research, but they're also having to get into advocacy. They have to advocate in various ways, quietly, publicly, organized, informal. What is your experience in this? Do you find that this knowledge that you are generating from your research, do you play a public advocacy role?
This is key to the actual dissemination of this information. So we're creating all these studies and developing them academically. And from my kind of experience being involved so I'm part of the Sustainability Committee at the Order of Engineers and Architects. So that's one dimension. We do conferences and workshops, etc., to inform the larger professional body about these issues. A second dimension is, for example, the Lebanon Green Building Council. So this is an important NGO. So I'm a founding member and an actual board member now, working a lot on enhancing awareness and educating people as of early ages. So this is starting in schools. So we have representatives that go to schools, talk to students about these issues in a way that the students at an early age understand the importance of these and kind of grow up with this awareness and sensibility to these issues.
We have time for one last question. Professor Aram Yeretzian, what is your next research priority in this field?
Digging deeper into this subject, there's still a huge amount that we need to understand and look at and identify as opportunities. So the academic and research aspect is one. The second is, in fact, education, so at multiple layers. So other than educating the students, so a lot of students work on these projects with me, and I actually kind of align this research with the courses that I teach in terms of response to climate, and educating the students on the importance of these beyond the academic context is, right, I think, key in terms of propagating this issue into the future.
Encouraging them to get involved in public advocacy, political work, social work, etc. And in terms of hard research, scientific research, what's your next focus in the work you're doing, looking at individual buildings or the urban fabric?
So understanding more how buildings interact is now kind of on my list of things to do. The issue is that, again, our sensation of comfort, of environmental comfort in the context, depends on how buildings relate to each other. I like the analogy of a building is a tree and the group of buildings are a forest. And we've learned a lot about. I read a lot about Willenbaum. How actually trees interact in a forest, right? That analogy would be very suitable for buildings. Buildings need to interact together in terms of energy, in terms of water, in terms of infrastructure, so that we really enhance and make the infrastructural system much more efficient, as it should be in the future.
Well, please hurry up with this research, because we got to beat the climate change challenge. We've run out of time. Professor Aram Yeretzian, thank you very much. Professor Yeretzian is assistant professor in the Department of Architecture at the Maroun Sam'an Faculty of Engineering and Architecture at the American University of Beirut. That's the end of our show today. Thank you for being with us, and I hope you'll join us again next week for another episode of Professors at Work, where AUB scholars and faculty tell us about the research they're doing, what they're finding, and why it matters. Bye for now.
Thank you very much. Thank you for this opportunity.
Thank you. Bye for now.